Question 1. Through the lens of real-world application, Anthony, a certified pipefitter, is tasked with joining 2-inch copper refrigeration tubing in a high-pressure HVAC system using brazing. The ambient temperature is 38 degrees and the surrounding work area is exposed to drafts. He prepares the joints, selects an oxyacetylene torch and chooses silver phosphorus alloy with melting point of around 11.9 degrees. Despite proper cleaning and fit up, he had poor capillary action and incomplete joint penetration after cooling. What is the most likely technical reason for this failure? A. The draft in the area reduced flame temperature below alloy activation threshold. B. The tubing material was incompatible with silver phosphorus alloys. C. The torch was too large for the pipe diameter. D. Preheating the joint area wasn't necessary due to ambient temperature. Answer. Correct answer A. Explanation. Capillary action in brazing depends on adequate and uniform heat across the joint. Drafts can lower the effective flame temperature, especially at low ambient temperatures, hindering proper alloy flow and wetting. ANSI 0.1 and OSB 0.2 recommend shielding brazing zones from airflow and preheating in cold conditions. Option B is incorrect since silver phosphorus alloys are generally compatible with copper. Option C could cause overheating, not underheating. Option D is incorrect. Preheating is necessary in low temperature or draft-prone environments. Question 2. In the context of hydronic system design, which of the following changes is most likely to reduce pressure drop without increasing pump energy consumption? A. Increasing pipe diameter and maintaining flow velocity. B. Adding additional 9-tie elbows for layout convenience. C. Using flexible piping with smaller internal diameter. D. Reducing pipe insulation thickness. Answer. Correct answer A. Explanation. Increasing pipe diameter reduces velocity and friction loss per the Darcy-Weisbach equation and ASHRAE fundamentals. Low velocity results in low Reynolds number and reduced pressure drop, improving efficiency without raising pump load. Option B adds turbulence and increases equivalent pipe length. Option C increases velocity and friction. Option D affects heat loss, not pressure dynamics. Question 3. As illustrated by a commissioning scenario is Delgado's pressure testing, a newly installed refrigerant piping system using dry nitrogen. The system is rated for 400 psi maximum operating pressure and the manufacturer recommends a 450 psi test. After pressurizing, she notices a 5 psi drop over 24 hours despite no visible leaks. Which step should is Delgado take next? A. Repressurize and assume temperature variation caused the drop. B. Spray soapy water at pull joints to find microleaks. C. Verify ambient temperature changes and recalculate pressure differential. D. Increase pressure above 500 psi to verify integrity. Answer. Correct answer C. Explanation. Pressure in closed systems varies with temperature. Gay-Lussac's law. AS B.5 and EPA section 608 note that minor pressure drops over long durations may be due to ambient changes. Recalculating using pressure temperature charts for nitrogen can confirm if drop is expected. Option A is premature. B is useful, but not before evaluating temp influence. D violates code. Exceeding 1.25x design pressure is unsafe. Question 4. When analyzing heat exchanger efficiency, what design factor most directly contributes to maximizing thermal transfer between refrigerant and water in a brazed plate heat exchanger? A. Minimizing turbulence within the channels. B. Using thicker plate walls for strength. C. Counterflow arrangement between fluids. D. Operating near freezing point for water side. Answer. Correct answer C. Explanation. Counterflow design ensures the temperature gradient remains high throughout the exchanger, maximizing heat transfer as outlined in ASHRAE Handbook. HVAC systems and equipment. Turbulence enhances, not reduces, heat transfer. Thicker walls insulate more, reducing transfer. Operating near freezing risks laminar flow and freezing hazards. Question 5. Given the circumstances, Mr. Bishop is threading black steel pipe for a high-pressure steam application. He uses a die-head cutter, applies thread sealant, and over-torques the joint for a tighter fit. After installation, leaks appear under pressure. Which is the most probable root cause? A. The thread sealant was incompatible with steam service. B. Excess torque caused microfractures or deformed threads. C. Black steel is unsuitable for threaded steam piping. D. Pipe ends weren't chamfered prior to threading. Answer. Correct answer. B. Explanation. Over-torquing threads distorts the thread form or creates hairline cracks leading to poor sealing and leaks. SMB 201 advises proper torque limits to prevent deformation. Option A may contribute, but not as primary cause. Black steel is commonly used for steam, so C is incorrect. Chamfering aids threading but isn't the critical failure cause. Question 6. To better understand compressor applications, which of the following compressors is most suitable for? A large commercial chiller system requiring high efficiency and part load performance. A. Reciprocating compressor. B. Rotary vane compressor. C. Scroll compressor. D. Screw compressor. Answer. Correct answer. D. Explanation. Screw compressors excel in large capacity systems with efficient modulation across varying loads, as stated in RE standard 540. Scrolls are quiet and efficient but limited to smaller systems. Reciprocating compressors are less efficient with more maintenance. Rotary vanes are rare in HVACR chillers due to capacity limits. Question 7. While examining fluid behavior in piping systems, what effect does a sudden expansion in pipe diameter have on velocity and pressure? A. Velocity increases, pressure increases. B. Velocity decreases, pressure decreases. C. Velocity decreases, pressure increases. D. Both velocity and pressure remain constant. Answer. Correct answer. C. Explanation. According to Bernoulli's principle and continuity equation, Q equals A star V as pipe area increases, velocity decreases, and static pressure rises. This principle is critical in diffuser design. ASHRAE Handbook. Fundamentals explains this dynamic in hydronic layouts. Options A and B incorrectly correlate velocity and pressure. Question 8. Under the assumption that structural integrity is a priority, which of the following best describes the function of a spring hanger in a vertical riser system? A. It allows for lateral thermal expansion. B. It absorbs shock from water hammer. C. It compensates for vertical pipe movement due to temperature changes. D. It isolates pipe from acoustic vibration. Answer. Correct answer. C. Explanation. Spring hangers accommodate vertical thermal expansion contraction while supporting load. Per MSSB 58 and SMAC NADUC construction standards, they allow vertical movement without transferring stress to anchors or structure. Options A and B relate to different support types, guides arresters. D involves vibration isolators. Question 9. During the process of a retrofit project, Israel is assigned to braze piping near an occupied mechanical room. What is the first step she should take before lighting the torch? A. Ventilate the space using an exhaust fan. B. Inspect the torch for leaks and adjust flame size. C. Review the SDS for the filler metal and flux. D. Conduct a hazard risk assessment and obtain a hot work permit. Answer. Correct answer. D. Explanation. OSHA 1910.252 and NFPA 51 require a documented hot work permit and hazard assessment before ignition. This ensures all flammable materials are controlled and safety protocols are in place. Ventilation is critical but follows permitting. SDS review is helpful but not a prerequisite. Torch inspection is later in the sequence. Question 10. A detailed analysis of building compliance shows that a pipetting contractor installed refrigerant piping without labeling content, direction, or pipe type. According to ASHRAE and Inc. standards, what code violation is most directly involved? A. Failure to meet lead documentation standards. B. Violation of Inc. Section 1108 on identification of piping. C. Improper refrigerant charge calculations. D. Non-compliance with RE 700 purity requirements. Answer. Correct answer. B. Explanation. Inc. Section 1108 and ASHRAE Guideline 1.4 require clear labeling of pipe content and flow direction for safety, maintenance, and emergency response. Lead is not mandatory. Charge calculation, C, and refrigerant purity, D, are unrelated to labeling. Proper marking also aligns with ANSI R.1 standard. Question 11. Given the circumstances, Mr. Patel is performing refrigerant recovery from an old HVAC system. He notices the recovered refrigerant contains moisture and debris. What is the best course of action according to EPA Section 608 guidelines? A. Recycle the refrigerant on site using approved equipment before reuse. B. Vent the refrigerant to reduce moisture content. C. Immediately reclaim the refrigerant to meet RE700 purity standards. D. Dilute the refrigerant with fresh charge to lower contamination levels. Answer. Correct answer. C. Explanation. EPA Section 608 prohibits venting refrigerants. Contaminated refrigerants must be reclaimed by a certified facility to meet RE700 purity standards before reuse. Recycling A involves cleaning but may not remove all contaminants, so reclamation is necessary here. Dilution D is illegal and ineffective. Question 12. In a recent installation is new and noticed leakage at a flanged joint despite following manufacturer torque specifications. The joint uses spiral wound gaskets. What is the most likely reason for leakage? A. Use of a non-metallic gasket instead of spiral wound. B. An even bolt torque causing gasket misalignment. C. The gasket material was too soft for system pressure. D. Over-tightening bolts beyond recommended torque. Answer. Correct answer. B. Explanation. Uneven bolt torque can cause flange face misalignment and gasket blowout. S&B.5 emphasizes the importance of a star pattern bolt tightening sequence for spiral wound gaskets. Over-tightening D could damage gaskets but usually causes flange distortion, less common than uneven torque effects. Question 13. When considering thermal insulation of refrigerant suction lines, which factor has the greatest impact on preventing liquid refrigerant migration and maintaining system efficiency? A. Thickness of insulation relative to ambient conditions. B. Color of insulation jacketing. C. Installation of vapor barriers. D. Length of straight pipe runs without insulation. Answer. Correct answer. C. Explanation. Vapor barriers prevent moisture ingress that causes condensation and ice buildup on suction lines, minimizing liquid refrigerant migration issues, while thickness A affects heat loss. Vapor barrier integrity is crucial per ASHRAE handbook. HVAC systems and equipment, color B, and pipe length D are less relevant. Question 14. While evaluating a chilled water piping system, Mr. Lewis observes that some pipe hangers lack thermal isolation from the building structure, causing noise transmission. Which type of hanger would best mitigate this issue? A. Rigid steel clevis hangers. B. Spring hangers with vibration isolators. C. Adjustable rod hangers without insulation. D. Uninsulated trapeze supports. Answer. Correct answer. B. Explanation. Spring hangers combined with vibration isolators reduce noise and vibration transmission from pipes to structures. SSB 58 and SMACNA acoustic guidelines support this practice. Rigid steel or uninsulated supports transmit vibration directly. Adjustable rods alone don't isolate vibration. Question 15. Considering refrigerant piping in outdoor HVAC equipment, the system operates between -10° and 110° ambient temperatures. What precautions should Pipefitter take to account for thermal expansion and contraction in steel piping? A. Use flexible couplings or expansion loops. B. Install rigid anchors every 5 feet. C. Increase pipe thickness to minimize expansion. D. Rely on the pipe's elasticity without special design. Answer. Correct answer A. Explanation. Steel expands and contracts significantly with temperature fluctuations. Flexible couplings or expansion loops absorb movement to prevent stress and damage. Rigid anchors B. Restrain movement and can cause cracking. Pipe thickness C. Doesn't control thermal expansion. Elasticity alone is insufficient. Question 16. While servicing a pressurized refrigerant line, Thompson notices frost buildup on the service valve stem. What immediate safety measure should she take before continuing work? A. Wear insulated gloves and continue working carefully. B. Close the valve quickly to stop refrigerant flow. C. Depressurize the system to eliminate frost risk. D. Avoid direct skin contact and use proper PPE. Answer. Correct answer. D. Explanation. Frost indicates extremely cold refrigerant exposure which can cause frostbite. OSHA standards require avoiding skin contact and using PPE like gloves and face protection. Immediate system depressurization C may not be practical or safe without procedure. Quick valve closure B can cause pressure shocks. Question 17. In a hydronic system balancing scenario, Mr. Hernandez finds that a globe valve installed on a branch line is difficult to operate and causes pressure loss. Which valve type would be more appropriate to reduce pressure drop while maintaining control? A. Gate valve. B. Check valve. C. Ball valve with throttling capability. D. Butterfly valve. Answer. Correct answer. C. Explanation. Ball valves offer lower pressure drop and good flow control compared to globe valves per ASHRAE and manufacturer data. Gate valves are primarily for isolation, not throttling. Check valves prevent reverse flow. Butterfly valves offer control but may leak slightly, making ball valves preferable here. Question 18. Based on the information in a PID, a pipefitter notices a symbol indicating a valve with a diagonal arrow through it on the refrigerant suction line. What does this symbol most likely represent? A. Pressure relief valve. B. Thermostatic expansion valve (TXV). C. Flow control valve. D. Manual shutoff valve. Answer. Correct answer. B. Explanation. A valve symbol with a diagonal arrow typically represents which modulates flow based on temperature and pressure. ASME and ISA standards outline PID symbols. Pressure relief valves have different symbols. Manual valves lack arrows of flow control. Valves have distinct icons. Question 19. During a pump-down procedure, Mr. Simmons notices the system vacuum holds at 500 microns but rises steadily after closing the service valves. What is the most plausible cause? A. Leaks in the system or valves. B. Moisture vapor outgassing from internal surfaces. C. Compressor or migration into the system. D. Excessive refrigerant charge. Answer. Correct answer. B. Explanation. Moisture trapped inside the system can vaporize under vacuum, causing pressure rise over time. Per EPA and ASHRAE guidelines, leaks say cause rapid loss, but this steady rise is typical of outgassing. Or migration. C. Doesn't increase pressure. Excess refrigerant. D. Affects pressures differently. Question 20. A demonstrated by workplace protocol, Mr. Garcia arrives to service a compressor unit. What is the first essential step he must perform according to OSHA's LOTO standards before beginning work? A. Inform the supervisor and sign service log. B. Denergize and isolate all energy sources, then apply lockout devices. C. Bent refrigerant lines to atmospheric pressure. D. Test the system for voltage before servicing. Answer. Correct answer. B. Explanation. OSHA 1910.147 mandates denergizing all power sources and applying lock stags to prevent accidental startup. Informing supervisors. A. Is secondary. Venting refrigerants. C. Is unsafe and illegal without proper procedures. Voltage testing. D. Occurs after lockout to verify isolation. Question 21. In the context of material selection for a chilled water system in a corrosive environment, Mr. Robert must choose between copper and stainless steel piping. Considering corrosion resistance, thermal conductivity, and cost, which material best balances longevity and system efficiency? A. Copper, due to superior thermal conductivity despite higher corrosion risk. B. Stainless steel, because of excellent corrosion resistance despite lower conductivity. C. Copper, as it is less expensive and easier to install. D. Stainless steel, because of its lower initial cost and easy weldability. Answer. Correct answer. B. Explanation. Stainless steel offers superior corrosion resistance, especially in aggressive environments, improving system longevity per astom. Although copper has better thermal conductivity, corrosion can cause premature failure and efficiency loss. Cost is higher but offset by maintenance savings. Copper is more prone to corrosion in certain water chemistries, and stainless steel welding requires skilled labor but is standard in HVACR. Question 22. Based on the information, Mr. Wilson measures refrigerant temperature and pressure at the condenser outlet and evaporator outlet, respectively. The condenser outlet pressure is 150 psi with a corresponding saturation temperature of 100 degf, and the liquid refrigerant temperature is 110 degf. The evaporator outlet pressure is 40 psi with saturation temperature of 35 degf, and the suction line temperature 45 degf. What is the calculated subcooling and superheat, and what do these values indicate? A. Subcooling 10 degf, superheat 10 degf. The system operating normally. B. Subcooling 10 degf, superheat 10 degf indicates overcharge. C. Subcooling 0 degf, superheat 0 degf indicates improper metering. D. Subcooling 15 degf, superheat 5 degf indicates low load. Answer. Correct answer A. Explanation. Subcooling equals liquid temperature. Saturation temperature equals 110 degf. 100 degf equals 10 degf. Superheat equals suction line temperature. Evaporator saturation temperature equals 45 degf. 35 degf equals 10 degf. Both values fall within typical operating ranges, indicating adequate charge and proper metering per HVACR diagnostic standards. Fundamentals. Deviations suggest overcharge, undercharge, or metering issues. Question 23. From a practical standpoint, Lee is insulating refrigerant suction lines in a high humidity environment to prevent condensation and corrosion. Which installation practice is most critical to ensure long-term insulation performance? A. Using closed-cell insulation without vapor barrier. B. Applying a continuous sealed vapor barrier jacket over insulation. C. Leaving insulation ends open for ventilation. D. Using thicker insulation layers without any vapor barrier. Answer. Correct answer B. Explanation. A continuous vapor barrier prevents moisture ingress that causes insulation degradation and corrosion under insulation. QE is emphasized in ASHRAE Handbook and NACE standards. Closed-cell foam alone is not sufficient if vapor can enter at joints or seams. Open ends. C. Invite moisture. Thickness without barrier. D. Does not prevent vapor intrusion. Question 24. While examining a brazing operation near flammable materials, Carter must follow strict safety protocols. What is the most important compliance step before beginning the work? A. Use fire-resistant blankets to protect nearby surfaces. B. Have a fire extinguisher on hand. C. Obtain a hot work permit and perform a hazard assessment. D. Use a high oxygen flame for faster brazing. Answer. Correct answer C. Explanation. NFPA 50 mandates obtaining a hot work permit and conducting hazard assessments to minimize fire risks before any brazing near flammable materials. Fire blankets and extinguishers are necessary but secondary. High oxygen flames increase fire hazards and are not recommended near combustibles. Question 25. In a chilled water system, Mr. Green notices cavitation noise from a pump despite correct installation. What is the most likely cause of cavitation, and how should he address it? A. Excessive discharge pressure, reduce pump speed. B. Insufficient net positive suction head NPR to increase suction pressure or lower pump elevation. C. Incorrect impeller rotation. Reverse motor wiring. D. Blocked discharge valve. A fully open valve. Answer. Correct answer B. Explanation. Cavitation occurs when local pressure drops below refrigerant vapor pressure, causing vapor bubbles and damage. Insufficient NPSH is the primary cause. Increasing suction pressure or lowering pump elevation raise the NPSH. Discharge pressure and impeller rotation. C. Less commonly cause cavitation. Valve position. D. Affects flow but not cavitation directly. Question 26. When evaluating a refrigerant system operating at 80 psi, Mr. Fox refers to the PT chart and notes the corresponding saturation temperature is 50 degf. If the measured liquid temperature is 40 degf at this pressure, what is the condition of the refrigerant and what should the technician infer? A. Refrigerant is subcooled, indicates proper condenser performance. B. Refrigerant is superheated, the system is undercharged. C. Refrigerant is saturated, the system is in balance. D. Refrigerant is flashing, the system has internal leaks. Answer. Correct answer A. Explanation. Liquid temperature below saturation temperature at given pressure indicates subcooling, meaning refrigerant is fully condensed and cooled, a sign of efficient condenser operation. Superheat applies only to vapor. Saturated refrigerant temperature equals saturation temperature. Flashing involves vaporization and pressure drops. Question 27. When assembling threaded galvanized steel pipe, Mr. Simmons notices difficulty in tightening joints and is concerned about leaks. What is the correct procedure to ensure a reliable seal without damaging threads? A. Apply excessive torque and use pipe dope liberally. B. Use thread sealant compatible with galvanized steel and tighten to manufacturer torque specifications. C. Wrap the threads with Teflon tape 3 times and over tighten. D. Use no sealant and rely on thread interference only. Answer. Correct answer B. Explanation. Thread sealants compatible with galvanized steel prevent leaks and corrosion. Manufacturer torque limits prevent thread damage. SMB 201. Excess torque A. Damages threads over tightening with tape. C. Can cause stripping. No sealant. D. Risks leaks. Question 20. As demonstrated by a troubleshooting case, Johnson finds that the evaporator coil temperature is significantly higher than expected despite normal compressor operation. Which component failure is most likely responsible? A. Expansion valve stuck closed. B. Condenser fan failure. C. Compressor valve failure. D. Expansion valve stuck open. Answer. Correct answer. D. Explanation. An expansion valve stuck open floods the evaporator, reducing refrigerant superheat and increasing coil temperature. Valve closed A. Restricts flow, lowering evaporator temperature. Condenser fan failure B. Causes high head pressure, not evaporator temperature rise directly. Compressor valve failure C. Affects compression. Question 29. While conducting leak detection, Stacati uses an electronic refrigerant detector near a suspected joint but detects no leaks. However, soap bubbles appear when he sprays a solution on the joint. What is the explanation? A. The electronic detector is malfunctioning. B. The leak rate is below the detector's sensitivity but visible via soap bubbles. C. Soap solution causes false positives on sealed joints. D. The joint is airtight. The soap bubbles formed due to surface tension. Answer. Correct answer. B. Explanation. Electronic detectors have sensitivity thresholds and may misbury slow leaks detectable with soap solutions. Soap bubbles form due to escaping gas creating pressure. Detector malfunction is less likely if properly maintained. Soap doesn't create bubbles on airtight joints. Question 30. Considering the evidence is that Allen installs a piping system with rigid supports spaced at long intervals without intermediate hangers, what is the most likely outcome? A. Reduced thermal expansion issues. B. Excessive pipe sagging and potential joint failure. C. Improved vibration control. D. Increased system flexibility. Answer. Correct answer. B. Explanation. Long unsupported pipe runs sag due to weight, causing stress at joints, leaks, or breaks. SMB.1 and MSS per 58 recommend proper hanger spacing. Rigid supports reduce flexibility and vibration control. C. D. Thermal expansion worsens without flexible supports.